In this video, we're going to be discussing some basic algebra properties that you should definitely remember from high school. All of these are high school Algebra 1 and Algebra 2 topics that we will end up using frequently in civil engineering. So let's get started. The first thing we're going to talk about very briefly is exponents. So you need to remember all of your exponent rules. Let's go ahead and get started. So if you have something, let's call it x raised to a power, let's call it n. X is known as the base. And then n is, of course, your power or exponent. Okay? So when you have x to the n power, what you are basically saying is you're multiplying x by itself n number of times. So this would be x times x times x dot 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 n number of times. So for example, if we say example, if we have x cubed, this is x times x times x. What if you have 2 to the 4th power? Well, 2 is the base, 4 is the exponent, and so you would have 2 times 2 times 2 times 2. So what do you get? You get 2 times 2 is 8. You know, you can write this maybe here. I'm sorry, 2 times 2 is 4, not 8. And then another 2 times 2 is 4 here. And so then you can say, what's 4 times 4? Well, that's 16. So the answer here is 16. So all that should be known to you. We have several other properties. We have what's called the product of powers. What does the product of powers say? This says that when you have x to the n times x to the m, you get x to the n plus m. So the thing to note here is that the bases are the same. Bases are equal. So when you look at the product of powers, your bases are equal, and then you add the exponents. All right? So, for example, if you have x squared times x cubed, what do you get? Well, you get x to the 5th power because you add the exponents, okay? Let's keep going. What about the power of a power? Power of a power. So power of a power, that would be like if you had x to the n and then raise it to the m power. So in this case, you would end up with x to the n times m. So what you do is you multiply the exponents. So an example of this would be like x squared cubed. This is equal to x to the 6th power. Notice it's different than our previous example. Okay, this is a different different property. All right, so that's power of a power. The next property we have is called power of a product. So for this property, we have 2 different bases multiplied together, but they're raised to the same power. So here we notice that we have 2 different values, okay? So when you expand this, we get x to the n times y also to the n power. So you can kind of almost think of this n as being kind of distributed to each of these different base values. So an example of this would be, for example, it would be, a, b, c to the 3rd power. What does this end up becoming? This becomes a cubed times b cubed times c cubed, okay? So that's power of a product. The next property we have is properties of negative exponents. So what happens when you have a negative exponent? For example, x raised to the negative n power. Well, that's equal to 1 over x to the positive n power. So what you do is you reciprocate. You take the reciprocal of the base and you make the exponent a positive value, okay? And then likewise, if you had 1 over x to the negative m, you can say 1 over 1 over x, 1 over x to the positive m, and this just becomes x to the positive m power. All right, moving on. What about a zero exponent? Zero exponent. So whenever you have a zero exponent, anything raised to the zero power is 1. So if you have something raised to the zero power, it's 1. If you have 12 to the zero power, it's 1. If you have 1,000 to the zero power, it's 1. Anything raised to the zero power is equal to the number 1. Next, we have quotient of powers. Quotient of powers. So if you have the same base, let's say you have x to the n divided by x to the m, you get x to the n minus m. Okay, now notice again, you have the same base here. Same base, but you have different exponents. So when you have the exponent term that goes into the denominator, that is what ends up being negated when you subtract these exponents, okay? And then we also have power of a quotient. Power of a quotient. Let's see if I can spell that right. So this would be like if you have maybe x over y, two different values to the n power, you get x to the n divided by y to the n. So this is very similar to the power of a product, except this is a quotient at this point. So you can think of this little exponent being distributed to the numerator and the denominator bases, okay? And then the last property here is we have exponent fractions. Exponent fractions, okay? So exponent fractions, that would be like if you have x raised to the n over m, that would be written as the square root of x to the n, not the square root, sorry, the mth root of x to the n power. So if you recall, for example, when you have x to the 1 over m, that's going to be the mth root of x. So, you know, an example of this, the classic example of this one, of this property is x to the 1/2 power is square root of x. X to the 1/3 power is the cubed root of x, so on and so forth, okay? So that's exponents in a nutshell. The next algebra property you need to make sure you're pretty familiar with is logarithms. Now again, logarithms is definitely an Algebra 2 topic, and then you may have gone into more detail with it in a pre-calculus course, all right? So for logarithms, you're going to have log of some base and then of a value, okay? So here, this is called the base, all right? So that's it in a nutshell. So when you have log of any base of 1, you get 0, okay? So log of any base of the number 1 is 0, all right? Next, if you have log of a base of the same number b, this is equal to 1, okay? The next property, I'm going kind of quickly now, but the next property of logs is log base b of n to the x power. What happens is this exponent comes out and it goes in front of the log. So this becomes x log base b of n. So that's like a power property. Next, if you have log base b of b to the x, this becomes x log with base b of b, and we just saw earlier that becomes 1. So this term goes to 1, and you're left with just x alone, okay? And in a similar way, you can say b raised to the log base b of x also becomes just x. All right. We also have the log of a product. Log of a product. All right. So this would be like log base b of x times y. This is going to be log base b of x plus log base b of y. All right. We also have log of a quotient. So log of a quotient would be like log base b of x divided by y equals log base b of x minus log base b of y. We also have what's called a natural logarithm. Natural log, okay? So we call this ln of x. Now, what is ln of x? ln of x is log base e of x. So e is what's called Euler's constant, okay? E is what's called Euler's constant, named after the mathematician and engineer. He was also an engineer, Leonard Euler. Now, what is E? Well, E is a constant, kind of like pi. It's 2.71828, and it keeps on going, kind of like pi does. Okay? So, again, Euler's constant, and that helps us define the natural log. We also have the change of bases of logs. Okay? So, we have the change of bases of logarithms. So when we have change of bases, what we can say is log base b of x can be written as log of another base, let's call it c of x, divided by log of that with that new base c of b. Okay, so usually C is taken as E, which is this Euler's number that we just talked about. Okay, so we often see log base b of x as written as ln of x over ln of b. Okay, and again, all of this should be a review from Algebra 2 from high school, maybe even Algebra 1. So that concludes our algebra review.